Hey everybody, Mr. Bowman here, another video on 3.13 probability concepts. In this video, we're focusing on all the merit questions from that 2019 exam. Let's get straight into it. Question number 1, and this question was a bit weird because you needed both parts to kind of get the merit mark. So even though it's merit, the first part's actually quite easy. So we've got a whole bunch of data. Given that the student is in middle school, calculate the probability that they were male. So for that part there, we need to find what's the probability that they are in middle school given they are male. So that's kind of what we're aiming to calculate here. We've got a whole bunch of information here. So the first port of call is trying to figure out what tool do I want to use. Is it a tree, a Venn diagram, the two-way table maybe there's some formulas. So let's have a look into the question. So we've got some school rule data from a provincial New Zealand primary school. And they've got some data by the year and the gender. There are 343 students in total. There's a certain number of female students, and we've got the split from the junior school to the middle school to the senior school. And then we've got some more information on the male, also split to junior, middle, and senior. So it looks like, I think this is going to be a two-way table. If we kind of draw a table, it's going to be split by male versus female. So what gender it is. And then the other one will be based on what part of the school they're from. So we've got J for the junior school. Because we've already got an M, let's do MI for middle school. And then we're going to use S for senior. And then let's draw an extra one so we've got enough room for all our totals. Okay. So it's now all about just infilling the question or infilling our table to then figure out. So we know 343, that was the first number given to us. And that related to the grand total, which is going to be down the bottom, 343. So we've kind of now considered that number there. Of the 149 female students, so we know this here is going to be 149. So I've now considered the female number. I can also work out the male number from that. So that's going to be the 343 minus 149, which gets me to 194. So based on this, it looks like there are more males than females in this school. So of the female students we're working on, 31 of them are in the junior school. So we've got 31 junior and junior and females. We've then got 65 in the middle school. So it's going to be 65 down here for the females. And then finally 53 in the senior school. So we've got all of those numbers there. Of the male students, so we've now got the male total. We figured that out before. 49 of them are in the junior school. So there's the 49. We've got 73 in the middle school. And then it just is the remainder in the senior school. So 73 is actually the last number that we've got there. So I guess the first thing we can figure out is we can figure out the senior portion there by doing 194 minus my other two numbers. And when I do that, I get to 72. And the last thing is just to figure out all the totals for each of the school level. And I can do that by kind of adding up to get to that bottom number down there. So when I do that, I get 80 junior school people in total. I get 138 middle school, and then I get 125 senior school. So I've got my table, and now I can actually start thinking about the question and answering it. So question I. And as I said, we're trying to find the probability that a random student is in middle school given they were male. So let's think of my fraction. My favorable outcomes divided my total outcomes. So my total outcomes relates to the males only, because we only care about the males from this particular table. So that's going to be out of the 194 males, which is up the top there. Of these 194, how many are from middle school? And that's going to be the 73 over there. So we've got 73 divided by 194. And I put that into my calculator. Don't forget fractions is division. So I've got 0.5290. And that there I've rounded to 4 decimal points. I'm now on to question or part II. So is it more likely that a student to be male if they were in junior school or if they were in senior school? So this is two conditional type questions. So we first need to find what's the probability that they are male if they're in the junior school. Oh gosh, that's a terrible J there. There we go, if they're in the junior school. And then we need to find the probability that they are male if they're in the senior school. So these are the two things we're going to calculate. Because this is more likely, you could probably do a relative risk calculation as well. So maybe that'll be the third part of my answer. And then once I've done that, I then need to just talk about my answer, and I'll probably do that down there. So let's start off by finding the probability that they are male given they are in junior school. So my junior school people is these 80. So that's going to be my denominator. So there's 80. And of these 80, 49 of them are male. And converting that to a decimal, I got 0.6125. No need to round that one because that was the exact number. We now need to repeat the same for the males who are in the senior school. So same thing, my denominator is going to be the total number of senior school students, which is 125. And of these 125, we know that 72 of them are going to be males. So we've got 72 over 125. And plugging that into my calculator, I'm getting 0.576. Again, no need to round that because it's the exact number. Now I've got my two conditional probabilities. I'm now going to go the big one divided by the small one to help me find the relative risk. So the relative risk of this is going to be 0.6125. All of that is divided by 0.575. And when I do that, that means I get 1.063. So because the number is greater than 1, that tells us this top group, which relates to the junior school, is bigger than the bottom group, which relates to the senior school. So that tells us males are more likely to be in the junior school when compared to the senior school. So we now just need to type that out. So this means that students in the junior school are 1.063 times more likely to be male when compared with the senior school. And then we've got our full stop. Don't need the full stop there because it gets the line. We are now on to question number 2, and there's a lot going here because question 2, 3, and 4 all are kind of back to back and relate to each other. But let's get into question 2 first. So it is suggested that snoring at night has the effect on student performance. Data was collected on whether or not a group of Year 13 students gained achieved or better in their final exam. It was found that 123 snorers, 91 of them got achieved or better, and then 78 non-snorers and 68 gained achieved or better. A student is randomly selected. Let S be the snoring students. Let E be the gained achieved or better in their final exam. Compare the probability of E given S and the probability of E and explain if they're independent. Okay, so I always like to start these questions, whenever you're asked to prove that things are independent, I always like to start with a bit of a sentence. So if event E, which is the exam result, and S, which is the snorers, are independent of each other, then, and this is when we're going to get a bit mathy, the probability of E given S must be equal to the probability of E. And these are the two kind of probability things they kind of said in the question to compare. So let's start thinking about how we're going to calculate these. So my initial gut, because we've got kind of snorers and whether or not people pass the exam, that's kind of two variables. So that made me think of a two-way table. So the people are either a snorer or not a snorer. And the E was those who got achieved or better in the exam. And then basically E dash is the people who didn't do that. So they're actually the ones who failed their exam. So let's make a bit of a table. So we've got our table sorted here. We were told that there were 123 snorers. So that's these people here. We were told there were 78 non-snorers. So that information was coming up from the question there and there. So you can kind of see me circling it up the top there. So of these 123 snorers, 91 of them passed. And of the 78 non-snorers, 68 of them passed. So we've got our table there. We can figure out our grand total here. So these two numbers added together gets me to 201. So that means there are 201 people part of the survey. This group here is going to be the 123 minus the 91. And hopefully I'm getting this right, but that's going to be 32. Down here, that's going to be 10 people there, which means that's 42. And my final number, I could do that by either adding these together or doing this minus this one here. Both will get you to the same answer, and I'm getting 159. So now that I've done that, I can now start doing my calculations. So the probability of E happening is going to be equal to, so that's 159 divided by the 201 people in total. So we've got 159 divided by 201, and that gets me to 0.7910. I now need to do the same calculation. So I now need to find the probability of E given S. So let's figure that out down the side here. Probability of E given S. So the S people, the snorers, that's 123. That's going to be my denominator. So 123. And of these 123, how many of them passed their exam? That's going to be the 91 up here. So we've got 91. I'm now going to convert that to a decimal. So that's going to be 0.7398. Again, rounded to 4dp. So I've got my two numbers, and now I need to answer the question by comparing them. So I said before, if they're independent, these two numbers should be the exact same. And whilst they're similar, they're about 5 to 6% off, which is quite different in terms of our probability. So we've now got evidence, because they're not equal to each other, events E and C are not independent. So we're now going to say that. So as the probability of E given S is not equal to the probability of E, we can confirm, oh, not sure why I'm adding the there. So we can confirm that event E is not independent to event S. So that means there's something going on there. There's some kind of relationship between the variables. One influences the other ever so slightly. Okay, we are now on to question number 3, and it says estimate the risk of receiving a not achieved. So don't forget that's E dash in their examination for students who snore versus doesn't snore. So we're trying to find the probability that they failed given they snore, and we need to compare that to the probability that they failed given that they don't snore. So the notation looks a bit messy, but it's enough to get us going. So let's start us off by finding that first one. So we need to find the probability that they fail their exam given they snore. So the snoring total we know is going to be 123. So these are the snorers, 123, and we know that 32 of them failed. So that's going to be our probability of people who fail the exam given they snore. And when I put that into a decimal, I'm going to get 0.2602, and that was rounded to 4 decimal points. I then need to repeat the same for my next one. So of the non-snorers, how many of them failed? So my non-snorers are down the bottom. So there were 110 of the 78 who meet that criteria. So 10 people of the 78, and converting that to a decimal, I've got 0.1282. Again, I've rounded to 4dp. Because it says the word risk, that's a big indicator. Maybe we've got to use relative risk to calculate this. So my relative risk, it's always equal to the bigger number divided by the smaller number. So I'm going to do this one divided by this one here. So we've got 0.2602, and that's going to be divided by 0.1282. And plugging that into my calculator, I'm going to get 2.03. So because it's a merit question, we always got to relate things back to context, which normally requires a sentence. We just got to interpret what this number means. So just a reminder, the top there, that was this number here, and that related to the people who failed given they snored. And the bottom number was the people who failed given they didn't snore. So that tells us the snorers are far more likely to get not achieved than the non-snorers. So we just need to put that in a sentence. So this means that the snorers are 2.03 times more likely to get a not achieved when compared to the non-snorers. So we are now on to question number 4, and we've got a group of 260 year 11 students. Noting the previous question was all about the year 13 students. We're now doing year 11 students. Assuming 127 of these have the same risk as the year 13 students who are snorers, and that the risk of receiving a not achieved is the same as the non-snorers for a year 11 and the snorers for a year 13. So basically what all this part is trying to say is it's trying to say the information we have from the year 13 data, which is still in our table there, is going to be the same, or it's going to be relevant for the year 11 students as well. So we've really just got these new totals, 260 year 11 students and 127 of them are snorers. So let's carry on with that part there. How many of the group of year 260 year 11 students would you expect to gain achievement or not? So let's start by thinking our totals. So we've got snorers, we've got 127 snorers, which means our non-snorers, we've got 133 of them, which is going to be 260 minus that 127. So I guess another thing to note is down the bottom there, it says the word expect, which makes me think it's going to be the expected value type calculation. So what I need to do is I need to do something to do with n times p. And I'm probably going to need to do this twice, one for the snoring group and one for the non-snoring group. So let's start off with the snoring group. So I've got 127 snorers, and I need to multiply that by the probability of a snorer getting a achieved or better. So we got snorers, which is this group of the table here. And the probability of the snorers getting achieved or better is this 91 out of the 123. So I need to go 127 times 91 divided by 123, because that's the probability of a snorer getting achieved or better in the exam. I now need to repeat this. I need to go plus 133 times. So this is the non-snorers now. So the probability of a non-snorer passing the exam was 68. So these 68 out of the 78. So we're then going to go 68 over 78. Doing the calculation, so we did the snorers first. So that came up to, I think it was 94 snorers, and that was rounded to the nearest whole number. And then repeating the same over here, that is about 115.9. So we're going to round that up to 116 because you can't have part of a snorer. So these were both rounded up to the whole number, which means in total we're expecting 210 of these 260 year 11 students to actually pass. The final question, and don't forget these are all from the website, but question 4B because I forgot it the first time around and had to add it in after I finished all the other questions. But we've got 3 types of social media used for young adults: Instagram, Snapchat, and Facebook. We've then got a whole bunch of information. We can see all the numbers kind of popping up here. So Instagram reports about 80% of the users are from outside the United States. The logical inference from there means 20% of them are from inside the US, with a large proportion of these users logging in daily. Of the non-US users, it is estimated that 47.5% of them log in every day, and of the US users, 60% of them log in every day. Given that the user logs in every day, are they more or less likely to be from the US, etc.? So the nice thing is whenever I see these of the US users, of the non-US users, for me that's normally a giveaway. A probability tree is going to be involved somewhere. So my first split is going to be, are they a US user or are they a non-US user? And we know the probabilities of that. So it said outside the US is going to be that 80%. So that means this group here down is going to have a probability of 0.8, which means the US would be 0.2 as their probability. And then we've got this 47.5 number. So that's of the non-US numbers, 47.5% of them log in every day. So this here is we're going to go at E for every day and then E dash for not every day. So this here is going to be 0.475, which means my bottom branch is going to be 1 minus that, which is 0.525. We're then going to do the same for the US one up here. So we're going to have every day and then not every day. And we were told 60% of the US users log in every day. So man, that's going to be 0.6, and we're going to have 0.4 down there. Okay, so we've got our tree. It looks pretty messy, but given they are users that log in every day. So let's not read the rest of the question. Let's first figure out and explore what branches of my tree log in every day. And it's going to be this kind of branch up here and this branch up here, right? So I'm going to calculate the probability of these two ones separately. So that top one up here is going to be 0.2 times 0.6. So that means this branch of everyday users is going to relate to 0.12 of my overall probability. I then need to do the same down for the second branch. That's going to be 0.8 times 0.475, which gets me to 0.38. So these are the everyday login people. So we now need to read the question. So are you more likely to be from the US or not the US if you're one of these people that logging in every day? So let's do a relative risk calculation, because that phrase more likely kind of normally wants you to do a relative risk calculation. So we're going to need the probability that they are an everyday user given they're from the US. So that's the first thing we need to calculate. We then need to do the probability they're an everyday user given they're not from the US. So we're going to need to do these two calculations first. So the total proportion of people that are everyday users are going to be 0.5. So that's going to be my denominator for both of these fractions. And of the US users, 0.12. So 0.12 is going to be that. And then down the bottom there is going to be 0.38. And calculating or converting both of these to decimals. So the probability that someone is we're going to log in every day given they're from the US is 0.24. And this one here is going to be 0.76. So that's given they're not a US member, how likely are they to be an everyday user? I'm now going to do my relative risk calculation. And again, remember, it's always the big one divided by the small one. So we're going to do 0.76 divided by 0.24. And when I plug that into my calculator, I'm getting 3.17. Then going to interpret what this 3.17 number actually means. So that means the non-US numbers, because that was our numerator, are 3.17 times more likely to be the daily users given the US people. So let's go daily users of Instagram are 3.17 times more likely to be not from the United States than from the United States. That wraps up all of the merit questions for that 2020-19 exam. Hopefully you found them useful. I'm going to be smashing out heaps of other videos this week, so keep an eye out for them, particularly if you're studying for level 3 stats, probability concepts, and probability distributions.